And this is at, this might even be at County Materials. I can't remember which bridge producer I took this at. This is the end of a box beam form. You can see there's quite a bit more pre-stressing strand here than if we go back to the wall panel than you'd see here. And that's because there's going to be far more load placed on this than you'd see in a wall panel. One of the other things that you see is on the end of each of these, there's what's called a strand chuck. They're going to come and get the forms all ready, and then they're going to put that 35 or 40,000 psi of pressure on it, and they'll use one of these strand chucks. It's got a little O-ring in here that's got little teeth that will actually hold that strand with all of that pressure while the concrete is curing. So you can kind of see what that looks like. And you'll see in the plants that they're all just as clean as this one is. So it does get used quite a bit, but they do have to keep them up and keep them oiled and cleaned and ready to go. So then they stress the strand, and that's actually the most dangerous part of the manufacturing process. If one of those, occasionally in a plant, one of those strands will snap, give way, and then it usually will come back. So as you're touring through the plants, if you see any flashing lights and people standing behind big wire mesh cages, you don't want to stand on either side or behind that bed. You always want to stand away from it. It's not like it always happens. It just is one of the safety precautions. One of the other things that to keep in mind as you're going through the plants on Wednesday, you do want to wear hard-toed shoes. So you don't want to have any flip-flops or sandals, or you probably guys aren't going to wear high heels, but I've seen architects come in with high heels, and you don't want to wear those either. So they've got the pre-stressing in place, and then they're going to place the concrete in the form. Most of the precasters are now using self-compacting or self-consolidating concrete. Are you guys familiar with that at all? Let's talk a little bit about that so you'll know what you're seeing. As you're seeing these, the concrete mixes go in, the forms, a lot of times now they just can stop the mixer or stop the bucket, place the concrete in the form, and then it will actually level itself through the whole form and not require any vibration. A lot of the precasters are using an admixture that really does a good job of helping the cement coat all of the different aggregate in the mix. And that means that it's a little soupier and it also flows a lot better. Yeah?
We use that for a lot for highways.
Right, yeah. It is being, it's not like it's only being used in precast plants, but it is more expensive for the product, but the precasters like it because they save a lot on labor, because they don't have the guys there with the vibrators going along. Now, you're not going to see that in any of the DOT projects that require pre-stressing, because the DOT isn't allowing it in pre-stressed products yet, but they're finalizing an agreement to start to use that in the pre-stressed products as well. So that's one of the changes that we're starting to see. So self-compacting concrete, the architects like it a lot because it looks pretty, it's smooth, it's got a nice finish without a lot of bug holes or chips or dings. Precasters like it because they don't have to pay as much in labor costs. After the concrete is placed in, it's going to be cured. And we have outdoor plants in a lot of parts of the country. You're going to see County Materials is an outdoor plant for all of their bridge products. Lombard is an indoor company with all of the architectural products. This would be a large bridge beam being cured, and you can see that they've got a blanket over it. They're steam curing it. So even though it's outdoors, and even though they manufacture it year-round, they still control the temperature of those beds. So it still is all quality controlled and keep the temperature even, and that also helps speed the process as they come along.
How do they reconcile between 7 days quick setting of quick hardening and 28 days of
Well, it's not even 24 hours, it's overnight, so sometimes it's 12 hours strengths. They're looking at about 3,500 PSI, and they're usually looking at 28-day strengths of 7,500 PSI and up. Usually it's even higher than that, usually more like 10,000 PSI and up. But they're designing it for strengths of about 7,500. So they come in the next morning and check and make sure everything's in place. They look to make sure the concrete has reached that 3,500 PSI, and then they're ready to cut the strand. Now, when we looked at the strand earlier, we were talking about how it's like a steel rubber band. And the strand in precast is always, if you've got a beam like this, where do you think in the beam the strand will be placed? Any idea? It's always going to be placed in the bottom of the strand, and that's what's going to help create this arch or this camber. If you see what's on top, that would be a beam with no pre-stressing in it. So the weight of the concrete would actually create a load that would create this. This is supposed to be minor stress cracking. It always cracks me up when I see this slide. If you ever see minor cracking that looks like this, run for the hills. Don't go anywhere near it. But this is supposed to represent minor stress cracking. So you would see that on a beam without the pre-stressing in it. If you do have the pre-stressing, it would look like this because you've placed your pre-stressing in the bottom of the form. The precaster comes in, and as the concrete cures overnight, it actually will adhere to that steel that's being stressed at 35 or 40,000 PSI. So when the precaster comes in the next morning, they'll cut both ends of that strand. Well, it's being stretched like a rubber band, and it's cured. The concrete has cured and snapped around it, so it wants to snap back into place. Well, because the concrete's cured to it, it can't, and so instead it tensions all of that concrete, and you get this arch or a camber. As you're going through the plants on Wednesday, you'll actually be able to see this in the bridge beams. It's actually visible to the naked eye, so it's pretty interesting to see. Now, when the engineers are designing the precast, they can't actually design the camber. They can approximate what the camber will be, but they actually design it for the loads that are going to be on it, and that is going to create the camber. That's kind of a nickel tour through the manufacturing process. Does anybody have any questions about that? Okay. I thought I would take you through some of the, I thought I got rid of this. Okay, let's go back. I thought I would take you through some of the different details that you can get with precast and some of the trends that we're seeing. One is the sculptural shapes. We're really starting to see precasters being pushed more to do 3D sculptural shapes. And actually one of my members just did a project called Varsity Village at the University of Cincinnati. And they had 3D modeling used for all of the precast components on the exterior section. He did not have any right angles on the entire precast portion of the project. So it was pretty challenging to do that. And we're starting to see more architects and designers look for unusual shapes and sculptural pieces out of the precast. We're also seeing a lot of details being used. This is a hospital up in the Chicago area called Condell Medical Center, and this attention to detail with all of the different motifs is something that we're starting to see quite a bit on the products. We're also seeing a lot of color being used, more so than it was 10 years ago. In this case, this is stained. Concrete producers who do wall panels generally don't include the stain as part of their contract. The stains are usually part of the done at the job site and are part of the contractor's subs, but not part of the precast contract.